What we're going to talk about now is startup cost and how to keep that low, and how to spot design features that would contribute to a very high startup cost. And this is of course a very important topic for e-commerce sellers, because what we would like in a perfect world is to have a startup cost of 0, so that we can test our idea, test our product market fit without investing a huge amount up front. And I will talk about some examples throughout this lesson so that you get a sense for how much things could cost. But in the end, of course, the cost will be very specific to your project and to your product. With that said, let's jump into it and see if we can get your project cost as low as possible. The first thing that I would like to do in this lesson is to go through 3 of the most common manufacturing technologies and discuss their startup cost and their per unit cost as well. So how much does it cost to produce a part? And the purpose of doing this, it's not to make you a full-fledged mechanical engineer able to decide exactly which manufacturing technology to use in your product, but it's rather to give you some foundation so that you understand a little bit about how products are usually created, so that you are more informed when you are speaking with your engineers later on. So now let's jump into it and cover the first manufacturing technology that we will be talking about, which is injection molding. The basic way that injection molding works is by heating up plastic granulates and then pushing them under extremely high pressure into a mold. Then once the plastic has cooled, that mold will open and the final part will drop out. And injection molding is actually one of the manufacturing technologies with the highest startup cost. And the reason for that is that even before we can produce a single part, we need to create a mold. And a mold, that is something extremely expensive because it requires your part's shape to be milled very, very precisely out of either steel or aluminum. Now there are 3 main things that will impact the cost of your mold. And the first is the size of the mold, which is quite natural as a larger mold will require more milling, more material, and therefore be more expensive to produce. The second thing that influences the cost of the mold is the hardness of the material used. And depending on whether you go with steel or aluminum, and also which type of steel or aluminum you go with, you get a different number of cycles for which the mold will be good for, but you also get a different startup cost. So a steel mold, it will hold for a much greater number of cycles, but it will also cost much more upfront. On the other hand, an aluminum mold, it will be easier to mill and therefore less expensive, but it will also break down quicker and be able to produce less parts in the end. And deciding which material option will be best for you, it really becomes a math exercise that is influenced a lot by what budget you have up front and also how many units that you plan to produce. And then the third and perhaps most important factor that influences mold cost are complications. And a complication, that is basically anything that prevents the mold from being a simple 2-part mold. For example, we can take a look at this red bucket here on the screen and see that it is possible to mold it in a simple 2-part mold. So this one would have no complications. But if we design to add a hole on the side of the bucket for some reason, then suddenly we do have a complication, because now we need a third part to the mold to create this hole. And this is just one example of a complication, because there's so many different types and there's no point really in going through them, because in the end this is something that you need to train for a long time to be able to spot and to solve, and for that we will rely on a mechanical engineer later on. Now, apart from the generally high startup cost of injection molding, it is also a little bit of a tricky manufacturing procedure, because it's very difficult to estimate what your cost will be before having a final 3D model to evaluate. With that said, let's try to put some very, very approximate numbers on things so that you get a little bit of a sense for how much an injection mold could cost. To start off, I can say that it's very rare to see an injection mold below $2,000. For that to be the case, it would have to be something extremely, extremely small and simple. So something that could be molded in a 2-part mold. Now, if we're talking about more normal but still simple parts, like, I don't know, a Lego piece, for example, then generally the cost will land between $2,000 and $6,000. Then if we move to a little bit more complicated parts, with perhaps holes on the sides and a complex geometry, then we can very quickly get to mold costs of about $20,000. And then if we get to really large and very complicated parts with a lot of moving mold pieces and a lot of complex geometry, then the mold cost can easily reach 100,000 and beyond that. So those types of parts we should probably avoid unless we have a huge budget that we are willing to spend. And now to wrap up with injection molding, let's list a couple of key takeaways here. And the first one I would say is that you should avoid injection molding unless you're creating plastic parts in a high volume, so above 2,000 parts per year, I would say. And the reason for that is that the per part cost is actually really low with injection molding, which makes it an amazing technology for large volumes. But as discussed, the mold is so expensive so that if you're only going to produce a couple of hundred of parts, then it does not really make financial sense. Then the second takeaway that I would like to mention is to keep the parts as simple as possible when you're dealing with injection molding. And this is to avoid all of the types of complications which can arise. And again here, the mechanical engineer will be able to consult you on what simple really means. Next up, we're going to go through two more manufacturing methods which have much lower startup cost than injection molding and will likely be more suitable for e-commerce businesses which are just starting out. The first one of these methods that I would like to discuss is sheet metal bending. And sheet metal, it's really a beautiful way to create products at low startup cost and actually quite low per unit cost as well. You can think of this manufacturing method as a type of origami but with metal instead of paper. So what you do is that you cut out the necessary shape from a large piece of metal sheet and then you bend that into the desired shape of your product. And the beautiful thing about this is that it requires almost no tooling and also very little machine setup. And if one is creative with sheet metal design, it's actually possible to create some very exclusive looking products at an extremely low per unit cost. So as an example, we can take a look at this phone holder here, which looks quite nice, but likely costs just about $3 to make. That would be my estimate. And the reason for that is that we see that it's such a simple design to make. You cut out a piece of aluminum sheet, you bend it into the right shape, you put some surface finish on it, you assemble it, and there is your phone holder. And I'm not gonna linger on sheet metal any more than that, but I'm just gonna leave you with this key takeaway, which is that if your product can be envisioned in a type of metal origami design, then that is likely the most affordable option for manufacturing when balancing the startup cost and the per unit price. And then moving on to the final manufacturing technology which we will be discussing today, which is CNC milling, so computer numeric control milling. And this is a very simple method where you simply take a block of material, usually wood or aluminum, and then you start milling away the material that you don't want until you have the desired part. In general, CNC milling results in a quite high per unit cost due to the amount of time that it takes to mill out one part. However, if you do need a massive part of wood or metal, and then I mean massive in the sense that it's a very heavy part or that it has a lot of material inside of it, so a very thick part, then CNC milling could be the way to go. And this would be especially suitable for smaller volume productions, so perhaps only a couple of thousand units per year, or very, very high-end items where a higher cost is still acceptable if it improves the look of the product. Now on the upside, as with sheet metal, the startup cost of doing CNC milling it's extremely small because almost no tooling or manual labor is required. Let's wrap up CNC milling with some key takeaways. The first one I would say is that if you're selling a product in low volumes, so below 2,000 or perhaps 1,000 per year, and you are okay with a higher per unit cost, perhaps it is a luxury product, then CNC milling could be a good option. The second key takeaway that I would like to mention is that you should try to design for minimum material removal. So this is quite logical because more material removal means more machine time and more cost. So if you are creating a product that is very close to a rectangular block, then it's possible that the CNC mill will not have to do a lot of work and therefore the machining will be quick and affordable. If we now compare the three manufacturing methods that we have gone through, we can summarize their cost profiles in the following graphs. So we have injection molding with a very high startup cost but very low per unit cost. We have sheet metal with almost no startup cost and a fairly low per unit cost. And then finally we have CNC milling with low startup cost but a high per unit cost. And apart from these 3 manufacturing methods that we have gone through, there are of course many more out there. So the point of what we have gone through so far is simply to acquaint ourselves with the most common ones. And then just a couple of random notes around manufacturing which I think you will find helpful. Number 1 is that textile products usually require very little tooling, so they are affordable to get started. And then number 2 is that if your product includes any type of electronics, then your certification cost will go way up. So you will need to get the CE mark for European markets, for example, and then the FCC mark for United States. And there's a lot more to say about the certifications, but we will delve into that more in depth in an upcoming lesson. Now let's take a look at the template that is attached with this week's lesson and calculate a ballpark figure for approximately how much money we need to get to a first batch of products. So this includes the tooling cost, the development cost, and then the cost for actually creating that first batch. So let's go through these columns one by one. Now the first one, that is the product development cost, and that is what you pay your freelancers to develop your product. Then we have the tooling cost, which is the injection mold, for example, or whatever other tooling your manufacturer needs to get started. Then in this column, we have the minimum ordered quantity. And this is the minimum number of units that a manufacturer will allow you to order. Because naturally, a manufacturer will not be very interested in working with you if you reach out to them and say that you're only going to order 10 phone holders or whatever product that you are making. So the minimum order quantity for mid-priced items usually lies around 500, maybe 300 if you're lucky. But generally, I would say that 500 in minimum order quantity, it's a pretty good estimate for items that cost about $20 retail. And if you're selling a more expensive item, then the minimum order quantity will naturally be lower. And same thing if you're selling something extremely affordable like a toothpick, then the minimum order quantity will be much larger. Moving on, we have the next column, which is the product unit cost. And here we bake in all of the costs of producing a single product unit. And then finally, we have the column that shows the total startup cost. And you get this by adding up the product development cost with the tooling cost, and then adding on to that, you take the minimum order quantity multiplied by the unit cost. And in this example, we would get a $13,000 startup cost. And remember, this is just a ballpark figure for you to get a very general sense of how much you need to take your product to market. And there are many things that are not taken into this calculus, right? Such as taxes, certification cost, marketing cost, logistical costs. So this is only meant as a very rough estimate. And this brings us to the task of this lesson, which is to make a ballpark estimation for the startup cost using the provided template. And of course, I understand that at this point you don't know the product unit cost and you don't know the tooling cost because you have not even talked with an engineer yet. But you can make an estimation based on what similar products are selling for. So for example, if we say that we want to sell this phone holder and we see that they are selling for about $10 on Amazon, then we can make some very rough estimations and say that, well, if they are selling for 10, then probably the cost of manufacturing lies somewhere between 30 and 50% of that. So in this example, that would be between $5 and $3. Then we can also think about what type of manufacturing this product seems to use and make a very rough guess on what type of tooling we need to have here. And again, this is only to give a ballpark figure and to give you a sense of the type of money required to get to your first batch of products. So with that, I hope that you'll get some useful information out of this exercise, and I'll see you next lesson.